Your functions make promises. A docstring says the input lists are non-empty and equal in length, but nothing checks that. In this video, we work a full exercise, pairwise division, and finish it by raising our own value error. Then we meet the assert statement, one line that turns a docstring's promise into a contract Python actually enforces. Here's the exercise. Write a function called pairwise division that takes two lists, lnum and ldenom, both non-empty and of equal length. Go element by element and build a new list where each element is the corresponding division, with lnum holding 4, 5, 6 and ldenom holding 1, 2, 3. We compute 4 divided by 1, 5 divided by 2, and 6 divided by 3, and return those results in the new list. One more requirement. If ldenom contains any 0, don't let the code crash with a zero division error. Raise a value error with a nice message instead. The plan? Write the working code first, then add the error handling. One solution fits on a single line, a list comprehension. Return the list of lnum at index I divided by ldenom at index I, for I in range of the length of lnum. The key detail is what the I stands for. The I is an index, not an element. Range of the length of lnum counts 0, 1, 2, one index for each position, and remember the range call. Either list works inside the length call since they are the same length. Because the I is an index, lnum at I and ldenom at I are guaranteed to be matching elements, the same position in both lists. Here's the same thing written as an ordinary loop. Start with list L set to an empty list. Then loop, for I in range of the length of lnum, append lnum at index I divided by ldenom at index I. Finally, return L. Two choices matter here. First, we still iterate by index. If we looped over the elements of lnum directly, there'd be no easy way to grab the matching element of ldenom. With the index in hand, both lists are read at exactly the same position. Second, we have to use append. We can't assign to L at index I because L starts out empty, so position I doesn't exist yet. Append grows the list one result at a time. Run it on our example. Pairwise division of 4, 5, 6 over 1, 2, 3 returns the list 4.0, 2.5, and 2.0. Every result is a float. True division in Python always produces a float, so 4 divided by 1 comes back as 4.0, not the integer 4. The working code is done. Now for the error handling. Here's the problem case. Put a 0 in ldenom, say 1, 0, 3. The first pass divides 4 by 1 and appends 4.0. The second pass tries 5 divided by 0, and Python crashes with a zero division error and a traceback. That breaks the specification. We promised a value error with a message telling the caller exactly what went wrong. The fix uses the tools from the last two videos. Pop the code into a try. The whole for loop goes inside it. In the except, raise our own value error with the message ldenom should not contain 0. The code is short enough that putting the entire loop under the try makes no difference. On input that honors the docstring, the only thing that can fail in there is the division. Run it with the 0 again. The moment 5 over 0 fails, control jumps to the except block. And instead of a raw zero division error, the caller gets our value error. ldenom should not contain 0. Same failure point, but now the error names the contract that was broken. For completeness, there's another way to raise it. A raise doesn't have to be part of an except block. Before doing anything with the code, check if 0 is in ldenom, raise a value error with the same message. That guards the input up front, so no division is even attempted. Either version is perfectly fine. You can raise value errors wherever you'd like. Now for assertions. An assertion is still an exception that gets raised, just a very special type, one we mostly use as a defensive programming tool. Think back to docstrings. Our docstring promises that lnum and ldenom are non-empty lists of equal length. That text is the contract between the person who writes a function and the person who uses it. But a docstring is just text. Python stores it and shows it in help, but it never checks it and never enforces it. The user can hand us empty lists, and the docstring does nothing. Assertions make the function enforce its own contract from the specification. Here's the form, the assert keyword, then a condition you're asserting to be true, then a comma, and a message. To require a non-empty list, assert that the length of list L is not equal to 0 with the message L should not be empty. If the condition is true, the line does nothing and the code carries on as normal. If it's false, Python raises an assertion error, shows the message, and the program stops right there. The value of an assertion is where it stops you. A bad value that slips into one function gets passed along to the next, and by the time something visibly breaks, the bug is far from its source. That's what makes debugging hard. An assertion halts execution the moment an assumption about a parameter is not met, so a bad value never propagates deeper into the program. When you're debugging, that early, loud stop is exactly what you want. Apply this to some digits from the first two videos. Part of its contract is that S is a non-empty string. Everything from total down to the bottom of the function is exactly what we had before. The only addition is one assert at the top. Assert that the length of S is not equal to 0 with the message S is empty. Hand it an empty string and the condition is immediately false because the length equals 0. Python raises an assertion error with the message S is empty, and the variable total is never even created because execution halted on that first line. Hand it a fine input, and the assert passes silently and the function runs as normal. Final exercise. Add one more line to the program we just wrote, and assert that enforces pairwise divisions contract. The contract has two parts. The lists are non-empty and they have equal lengths. You can enforce it in one assert statement or as two separate asserts with two separate messages. Either is fine. Remember the pattern. What you write is the condition you're asserting to be true, and after the comma comes the message. First, equal length. Assert that the length of lnum is equal to the length of ldenom, with the message lengths differ. Second, non-empty. Assert that the length of lnum is not equal to 0 and the length of ldenom is not equal to 0, with the message empty list. Watch it work. Call pairwise division with 4, 5, 6 against a shorter list, holding just 1 and 2. The lengths are 3 and 2. The first condition is false and the program stops with an assertion error. Lengths differ. Those mismatched lists can't propagate any further, and we're forced to go check why the lengths disagree. Now call it with two empty lists. Both lengths are 0, so the equal length assert passes, but the non-empty assert fails. Assertion error, empty list. The docstring's promises are now enforced contracts. That's the full arc of defensive code. Write the working logic first with indices walking both lists in step. Replace a crash with your own value error, raised from an except block or straight from an if, so failures carry a readable message. Then assert your docstring's contract so a broken assumption stops the program at the door instead of sending a bad value deeper into your code. To practice what you just learned, this course has free exercises and AI-graded feedback on ludium.ai. The link is in the description.